Hello and welcome to today's lesson on resultant forces, which is part of the forces topic in GCSE Combined Science Physics. So in today's lesson we're going to look at linking Newton's laws of motion to movement. So if we've been successful and learned in today's lesson, we can state Newton's laws of motion, relate Newton's laws of motion to everyday life, and understand how resultant forces affect the motion of objects. So in today's lesson we're going to be covering the following part of the GCSE Combined Science Specification: 4.5.1.4 Resultant Forces, 4.5.6.2.1 Newton's First Law of Motion, 4.5.6.2.2 Newton's Second Law, and finally 4.5.6.2.3 Newton's Third Law. So one of the key ideas of physics is Newton's laws. These are the laws which determine how all everyday objects obey and determine the motion of these objects. So they were published by Sir Isaac Newton in 1687 in his book The Principia Mathematica. Now these laws explain all motion in the everyday universe. There are no exceptions to Newton's laws of motion. They could be considered the most important laws of the everyday universe. So these are the following three laws that determine the motion of all objects in the universe. First one, the law of inertia. All objects will travel at the same velocity, which is inertia, unless it is acted upon by a resultant force. So a resultant force causes acceleration. Inertia is the tendency of objects to continue in their state of rest or of uniform motion when there is no resultant force acting on it. So inertia is the tendency of objects to remain at the same velocity unless a resultant force acts on it. Now a resultant force is an overall force on the object. It's a combination of forces on an object. Now we can calculate the resultant force by finding the difference between forces in the same plane. So in this example, the resultant force is 20 up minus 10 down, so equals 10 newtons upwards. Now one force can be considered as a negative as it's moving in the opposite direction. Now the length of the arrows in your free body diagram helps you understand the values of these forces. Now the resultant force can replace the other forces in a diagram. So the number of forces acting on an object can be replaced by a single force that has the same effect as the original forces acting together, the resultant force. Now objects will always accelerate in the same direction as the resultant force. Now the second law is commonly called F equals ma, which is the resultant force in newtons is equal to the mass in kilograms times by the acceleration in meters per second squared. So the size of the acceleration of an object depends on both its mass and resultant force. It's the mathematical interpretation of Newton's first law. This law indicates what two factors affect the acceleration of an object. Acceleration is directly proportional to the resultant force acting on an object. So we have acceleration on the y and resultant force on the x. We will get a straight line through the origin, because a graph which has a straight line through the origin as its line of best fit indicates direct proportionality. So acceleration is inversely proportional to the mass of the object. Now the full name of mass in this context is actually called the inertial mass. So the inertial mass is a measure of how difficult it is to change the velocity of an object. So the larger the inertial mass, the harder it is for an object to change velocity, the harder it is for an object to accelerate. So inertial mass is equal to resultant force divided by acceleration. So the definition of inertial mass is the ratio of force over acceleration. The larger the inertial mass, the greater the resultant force needed for the same acceleration. The larger the inertial mass, the greater the inertia of the object. Now this equation, F equals ma, must be memorized for your examination, and it's a very common equation used in examinations. Now the third law is that when two bodies interact, they exert equal but opposite forces on each other of the same type. This gives each object in the system a resultant force. This makes both objects accelerate. Now for this law to work, there must be two objects in the system. So for every example, we could consider two different objects. So a person and a ground, for example, a person and a ball, the plane and the ground. Now the forces produced are equal in size and type, but they act on different objects and have opposite forces. So this law produces the same resultant force on two different objects. Now this produces different accelerations if the objects have different masses. So let's just recap these laws of motion. The first law, all objects will travel at the the same velocity unless acted upon by a resultant force. A resultant force causes acceleration. In Law 2, F equals ma. The resultant force is equal to the inertial mass times by the acceleration. And the third law, when two bodies interact, they exert equal but opposite forces on each other of the same type, where inertia being the principle that a moving object has a tendency to have the same velocity as long as there is no resultant force. Now we can use a free body diagram to determine the resultant force on an object. For objects in the same plane, you must sum the forces together. However, if a force is in the opposite direction, it's given a negative sign. So here the two forces are summed as they're both in the horizontal plane. However, 60 is in the opposite direction, so it must be a minus sign. So the resultant force in this case is 100 minus 60, which is 40 newtons in the forwards direction. This means the object will accelerate forwards, which means it'll change either speed or direction. You can then calculate the size of the acceleration by using the resultant force equation, which is the second law of motion. So acceleration is going to be resultant force over inertial mass. In this example, it's 40 newtons over 400 kilograms, which is 0.1 meters per second squared. So this tells us that the larger the mass, the lower the acceleration for the same resultant force, and it means the smaller the mass, the higher the acceleration for the same resultant force. So let's just summarize what we've learned in today's lesson. A number of forces acting on an object may be replaced by a single force that has the same effect as the original forces acting together. This single force is called the resultant force, and you should be able to calculate the resultant force of two forces that act in a straight line. Newton's first law is that if a resultant force acting on an object is zero and the object is stationary, it remains stationary, but if the object is moving, the object continues to move at the same speed and in the same direction, so it will move with the same velocity. So when an object travels at a steady speed, the resistive force must balance the driving force. So the velocity of an object will only change if a resultant force is acting on an object. So you should also know the idea that the tendency of objects to continue in their state of rest or uniform motion is called inertia. Newton's second law is that the acceleration of an object is proportional to the resultant force acting on the object, but inversely proportional to the mass of the object, which as an equation is equal to F equals ma. You should also be able to explain that inertial mass is a measure of how difficult it is to change the velocity of an object, and inertial mass is defined as a ratio of force over acceleration. Now Newton's third law is that whenever two objects interact, they exert equal forces on each other that are equal yet opposite. And you should be able to apply Newton's third law to examples of equilibrium situations. So if you've been successful and learnt in this lesson, you should be able to state Newton's laws of motion, relate Newton's laws of motion to everyday life, and understand how resultant forces affect the motion of objects. So I hope you've enjoyed today's lesson on resultant forces, which is part of the forces topic in GCSE Combined Science. Thank you very much for watching today's lesson, and as always, have a lovely day.